Hey, good morning class. Today we're going to talk about solving inequalities. So yesterday we talked about equations and we learned a lot about that. So today we're moving on, and these are really similar, but today we're talking about inequalities. Okay? So first off, an inequality is a statement that two quantities are not equal. And it uses one of the following symbols to show you that those are not equal. First off, you have your less than sign, and you have your less than or equal to sign. You also have your greater than sign and your greater than or equal to sign. Okay? So this one would be telling you that whatever's on this side is less than whatever on this side. And this one is telling you that whatever is on this side is greater than whatever is on this side. Okay? So we have less than or equal to, greater than or equal to. Notice that the equal to ones have a line underneath the inequality. A solution to an inequality is any value of the variable that makes the inequality true. So if we look at this inequality here, we have x is less than 3. So values that would make this true could be anything that's less than 3. So I could say x would equal 1, and that would be true, because 1 is less than 3. That is a true statement. All right. How about if I said x equals 4? Is 4 less than 3? Nope. So that is not true. All right. So a solution would be this guy right here, any value that makes that true. So we could go 1, 2, 0, and any negative number would make this inequality true. Alright, so next thing we're going to do is learn how to solve these inequalities, and since we learned equations yesterday, you're off to a great start because solving inequalities is almost exactly like solving equations. We even have the same types of inequalities as we do equations. So we've got one-step inequalities, we've got two-step inequalities, and we have multi-step inequalities. And hopefully those all sound familiar to you. So first off, with a one-step inequality, the first thing we're going to do, of course, remember we're always trying to get the variable by itself. We want it alone on one side of the inequality. So the first thing we're going to do is use our inverse operations to isolate that variable. Okay? So right here we have 4 times x is less than 20. The inverse of 4 times x would be divided by, so we're going to divide by 4, so those guys would cancel out. 20 divided by 4 is 5. Bring down your inequality, bring down your x. All right? So as you can see, we can solve this exactly the same way as we solve equations. Over here we see that we have a two-step inequality. We want to get rid of our constant first, so we add 5 to each side. Then we get rid of our coefficient, so we divide by 4 on each side, and we get x is greater than 5. And in the last one here, we see we have a multi-step inequality. And the first thing we want to do here is look to see if we can simplify either side. Both sides are already simplified. Then we try to get all our variables onto one side. We see we have a variable here and a variable here. So I'm going to subtract x from each side. I get 4x minus 5 less than or equal to 15. Next thing I'm going to do is get rid of my constant. I'm going to add 5 to each side. And I'm going to get 4x is less than or equal to 20. And my last thing is to cancel out that 4, my coefficient. And I get x is less than or equal to 5. Now, it says up here that there's one extra step in inequalities. What is that one extra step? Well, down here we see we have a graph underneath each one. So our last step when we're talking about inequalities is going to be to graph your answer. So when you're graphing inequalities, the first thing you're going to do is locate your answer on the number line, or create your answer on the number line, which is the case here. So the first thing I'm going to do is draw a little dash. I'm going to write 5. The next thing we're going to do is we're going to have to draw a circle to mark that spot on our number line. Okay, so you can see I have a circle right there. Now, the key here is knowing whether to draw an open circle or a closed circle. Whenever we see a less than or greater than sign, we're going to draw an open circle. Whenever we see an equal to underneath it, we're going to draw a closed circle. So just to make that more clear, whenever you have less than or greater than, you'll use an open circle. Whenever you have less than or equal to or greater than or equal to, you'll use a closed circle. Now the reason for that is all of our answers for this would have to be less than 5. If you think to yourself, 4, is that a solution to this inequality or not? Well, 4 is less than 5, so yes, that's a solution to this inequality. Well, how about 5? Is 5 a solution to this? 5 is less than 5? No, it's not. So 5 is not less than 5, so that would not be a solution. So we put an open circle here because we're not including the 5 in our answers. We're only including numbers less than 5. All right, next thing we need to think about is on our number line. Which way do the numbers go? Well, as we go to the right, we know the next one would be 6, and the one to the left would be 4. We want all the numbers less than 5, so we're going to draw our arrow going this way. This arrow represents that the solution to our inequality is all numbers less than 5. Alright, on this one we see that our answer says x is greater than 5. So again, I'm going to draw my dash on the number line and label the number 5. We see that this is a greater than sign, and we know that greater than means an open circle because we're not including the number 5 in our solution set. So I'm going to draw an open circle, and now it says x is greater than 5. So if we're looking at our number line, which way will the numbers get bigger? Well, they're going to get bigger as we go to the right. Well, we want to include all the bigger numbers, so we're going to make our arrow go to the right. Clean that up a little bit. And on our last one, we see that x is less than or equal to 5, so again we're going to draw our line, we're going to draw our 5. This time we're going to draw a closed circle because it is equal to. So we draw a closed circle at 5. And it says it's less than or equal to, so we want the smaller numbers, so that's going to be going to the left. Alright, so that is our one extra step. We need to graph our answers each time. Alright, so there's one extra step, but there's also one big difference. Alright, we can see all these were solved exactly the same way as an equation, but you will get some occasions in inequalities where there's one thing that's completely different. So, let's solve this, and again we're doing it just like equations. So the first thing we're going to do is identify our constant, which is going to be the 5. That's our constant because it doesn't have a variable. So we're going to get rid of our constant first. We're going to add 5 to each side. We'll bring down the negative 4x. That's greater than 20. 15 plus 5 is 20. These cancel. Now we have negative 4x is greater than 20. We're going to divide by negative 4 on each side, because we want to get rid of our coefficient next. Here's the key. Whenever you divide or multiply by a negative number, you must flip the inequality. Okay? So you can see here we're dividing by a negative 4, so instead of having a greater than sign, we're going to flip, and we're going to have a less than sign. Everything else is done the same way. Negative 4 and negative 4 cancel out, so we get x is less than negative 5. Okay? So the only difference is whenever you divide by a negative number or multiply by a negative number, you must flip the inequality. We see we divided by negative 4, so we flip, and now we have x is greater than negative 5. We're going to box our answer. And of course we have to do that one extra step, which is graphing. So we'll draw our number line, put a dash, label negative 5 on your number line. This is going to be an open circle because it's less than. And also because it's less than, we're going to be going to the left because we want to include all our numbers that are less than negative 5 or smaller than negative 5. Okay? So those are the two differences with solving inequalities. That's how different it is from equations. So you can see they're very